rising and the shining cannot be postponed indefinitely. Though shining isn't compulsory in this intractable world, the rising eventually is.
All right, too much stuff to cover today to screw around in any fashion, folks, including a coronal mass ejection. We didn't even put it in the title. We just went live as quickly as possible. It is indeed an Earth-facing coronal mass ejection. It's not super high speed, at least not yet. Some of the plasma is still being held in place by that sunspot. This region right here, and you can see the date stamps down there. That coronal mass ejection happening at about 1800 UT yesterday. So there you have it. We did look at it on this LASCO C3 too, and it is 100% Earth facing. So here's the view from the LASCO C2. Now this is LASCO C3 rather. This is from Earth. And pay no mind to these planets in the background. Let me just explain to our new viewers what we're looking at here. So here's the Earth-centric view, and you can see we've got, I believe it's, yeah, Mercury, Saturn, and Jupiter are out there on the other side of the Sun. Stereo A is located out here someplace behind the Earth's orbit. So it sees space weather ahead of the Earth. So here's the view from Stereo A, and you can see that plasma being ejected there. And indeed it is Earth-facing, although it's still not, perhaps it's not entirely released yet from the corona, but it's quite distant from the Sun already. From that view, as you can see it in the LASCO C3. So there's the LASCO C3 view, and you can see the date stamps there. Again, that's Jupiter, Saturn, and Mercury are the bright objects you see. And you can see a little bit of diffuse plasma. It's not a very dense coronal mass ejection, and it's not yet at high speed. But again, it's still, as far as the Stereo A images go, looking like it's a bit connected yet to the corona. So anyway, let's go look at the solar disk directly. And there's that sunspot group 2755, which is still barely a sunspot. And again, surprised that it's still there. I did forecast for this to degrade more quickly than it has. So you can't be right all the time, folks. If you keep it over about 97%, you'll be good, though. Now, the most interesting thing is this active region rising here. It's very close to the solar equator, and it could be associated with cycle 24 activity. So we'll be looking at the polarity as that likely sunspot rises up over the eastern limb. And let's look at another view here. Here's the view from the intensity gram, and you can barely see that umbra right where my pointer is. And here's the view in 193 angstroms. And there you can see the sunspot in the bottom of the screen, as well as the active region rising in the upper left. And that is about 9 hours of activity just on today, January 6th. So some plasma headed your way, folks. It still could miss the Earth to the east, is my official forecast, but it's currently appearing to be Earth-facing. Here are the fields associated with sunspot 2755. And there's the 171 angstroms view faded to magnetogram. And you can see that cycle 25 sunspot has created some very symmetrical sort of features there. And I wouldn't be surprised if that produces a little bit of X-ray flaring throughout the day, although not very extreme X-ray flaring. I would also note once again how X-ray flares are not necessary for coronal mass ejections to be headed toward your doorstep. There's the active region, and I won't fade that out to, well, there's the likely sunspot that's rising. I won't fade that out to magnetogram as we can't see the, let's say, the chromosphere in this situation. By the way, if you're not viewing this live on Twitch, you're not seeing it live, twitch.tv/smAsho is the current live source for the videos, as we have to keep some content exclusive. So anyway, thanks everybody viewing wherever you happen to be viewing it. Let's get back to data like the GOES X-ray flux. And again, I wouldn't be surprised to see some B-class flares, perhaps even C-class flares, as the size of those magnetic structures has been significant. 10.7 centimeter radial flux is at 72, what you'd call solar minimum conditions. We did experience an increase in the solar wind, hitting a very weak magnetosphere, and as a result, we saw the KP get all the way up to 4. Sorry, patrons, I didn't send an alert last night. It didn't seem too extreme, so I did see the KP4 alert come in. And those will be automated in the future, patrons, so don't worry. Anyway, the KP index has dropped back down to 3. And we're going to skip cosmic rays today, although we did cover it yesterday. We saw some interesting data, so perhaps watch yesterday's video at youtube.com/smAsho or at bitshoot.com/smAsho. Solar wind density super low, 0.95, not even 1 proton per cubic centimeter, and solar wind speed still elevated, at least from where it was, as it got all the way down below 300 kilometers a second. Now the current reading is 498 kilometers a second. And there you see the data from ACE showing the extremely low solar wind densities we saw yesterday, below 1 proton. In fact, I saw somebody post a screenshot of 0.0 protons per cubic centimeter. Now that is a weak solar wind. Now I noticed somebody was talking about electron content, and so I put up the animation of the total electron content forecast. When a GPS satellite communicates with you on the ground, it has to communicate through these electrons, right? And so around noontime especially, you get a plethora of electrons, especially around the equator. And from experience, I can tell that these little blobs here, we're talking about TECU. I don't even know what that unit is, honestly. It's just an electron count. So electron density is what we're looking at here. Because these maps are shown in different units. Some maps will show you anticipated GPS error. So the anticipated GPS error on these heaviest shells here are going to be somewhere in the realm of 20 or 30 meters, which isn't really that bad. Those areas probably got to maybe 50 or 60 meters. And let's just say, if you follow me on Instagram, instagram.com/smAsho, you've seen some interesting bike rides where I had average speeds of 10,000 miles per hour and so on. And those readings are caused by the electron content. We had very high electron flux days, and we did a great demonstration of how they're affecting things. So I don't know how I got a tab missing, folks. I apologize. For some reason, we're missing the total the GOES electron flux. Get that back up on screen for you here, as this one here on solon.info is measuring relativistic electrons. And we see a small uptick there, but we're still in quite a low to moderate range at best. And regarding the lower energy electrons, looking at completely cratered electron flux there on the GOES 16 and 14 measurements. Ionosphere, I haven't looked at this yet. Let's see if we see any anomalies kicking up as we see some serious changes in the environment in the past day or two. We're looking at 6 hours of data here, courtesy Government of Australia, Meteorological Bureau. And we just see an extremely discharged northern hemisphere ionosphere, and quite a big disparity there between the charged and discharged portion. Discharged portion showing up in red, folks. That's an F layer. And the rest of these are F2 layers, right? Every place, for instance, the yellow areas, that's where a double layer has formed in the ionosphere. And it's looking a little less anomalous in the South Pacific, if you ask me, as we've been monitoring anomalies in the South Pacific down in this area, south and southeast of Hawaii, southeast of Hawaii, I'll say, for about 6 weeks. And let's look at some more stuff. Ghost magnetometers have been getting pretty wild here, and it's not surprising as we see some activity rising. So there's a sunspot right in the Earth-facing region right now. There is a coronal mass ejection headed our way, and another region rising. So don't be surprised if you see more oddities in the GOES magnetometer. Here's the data from Gong 2. And we're looking at the top view ecliptic plane field plot. Those of you not aware, this is stereo A out here, which is one of the magnetometers used to create this model. This is stereo B. And again, that active region looks like it's right on the equator, likely cycle 24 behavior, and unlikely to affect the charging of the current sheet. Still expecting about 36 more hours in the South Pole oriented portion shown in red. And let's look at the magnetosphere movies as we do most days.
This is $50,000.
And this is 4 hours of data, the most current data, that is, from the University of Michigan geospace model. We've got a very smooth magnetosphere right now. And here are the magnetic perturbations on the ground level, geospace delta B, changes in the Earth's B field, the field that goes through the magnet. Not to be confused with the poloidal fields, the ones that come out of the ends of the magnet. Poloidal versus toroidal. Understand the difference, folks. We'll talk about it sometime on the forums. And again, thanks everybody for tuning in and leaving comments. Holla! And there's 4 hours of data, your ground magnetic perturbations as we see the South Pole creeping into the southern Indian Ocean. And if you weren't aware, we've got 2 North Poles right now during this magnetic excursion. It's a weird time to be alive, folks. Let's look at earthquakes. Here's the past 24 hours, and I'm just going to slowly scroll up as we see nothing over a 6 magnitude. There is a deep quake in Fiji. That one's at 576 kilometers and a 4.7 magnitude. Looks like the largest of the past 24 hours was this 5.6 north of Ascension Island off the west coast of Africa. So a bit of a downtick in earthquakes there. Let's talk about science in general. Check out this article from Our Finite World. Were you aware that scientists have a tendency to prove whatever their funders would have them prove? Thanks, Gail Tverberg, for this article. Apparently, there's a sweeping tendency for scientists to believe stuff that isn't true as a result of their funding. I'll just scroll down if you want to read the article. Anyway, There's a lot of misappropriated funds when it comes to science, and that's part of the reason why we started our organization when we did, which you can read all about at smashomash.org. Check out our forum. California's failing with their transition to green energy, as we do not have the infrastructure to handle electric cars, wind power, or solar power, as the technology is not there yet, nor is the infrastructure. Someday, perhaps, but reducing fossil fuel use to zero will basically kill you. And so there's a reason why India and China aren't doing it, because it would kill them too. At least they're smart enough to admit it. Anyway, let's just head to a different page here. We left links to that article, by the way, below the video. And here's where pressure zones are currently. And let me disappear for a minute to show you where they'll be in 24 hours. Now, this is the GFS model on windy.com. By the way, windy.com has a fantastic mobile application. Download that to your device, perhaps. It's got so much data you can't believe it. And here's the time we made this video, 3:57 a.m. And I can't get it to pause. There we go. And I'm back. Anyway, we like to add some value-added services into the videos, and there is a reason why we have the tabs in the order that we have them. We're not just stagnating, folks. Anyway, here's the volcano list. Kluchevskoye on the Kamchatka Peninsula is erupting. Were you aware? It's exploding, indeed. Producing a 20,000-foot ash plume. That's kind of big. Mount Aso. I wouldn't fly over it in my ultralight John Denver style. Sakurajima, flight level 6,000 there. Mount Takono, flight level 7,000 there. Kerinci, volcanic ash scene moving east-southeast. Sangay, exploding, 19,000-foot ash plume there. Ravenador, also exploding, 18,000-foot plume there. And while Sabancaya's volcanic ash is not identifiable in the satellite image, please do not attempt to pole vault the Peruvian volcano. Were you aware that there's snow in places like Algeria, whatever it's called, Tunisia, Northern Africa? Yeah, it's true. There's an image. Check out this article from The Watchers. Apparently, the planet is so hot that parts of the northern African desert are cold enough to have all this snow. Must be from carbon dioxide, folks, because apparently carbon dioxide causes it to be hot, causes it to be cold, causes it to rain, causes it to not rain, causes the climate to go up, causes the climate to go down, and pardon the sarcasm. Check out the wildfires in Australia. It is a disaster. Shout out to Kimberly. And oh man, what a wreck. I mean, this is like historic fires in terms of humankind. By the way, those are all smoke plumes you see there. All those straight lines. They're not chemtrails. They're not contrails. And they're not Hall currents. Those are just wind-induced fire plumes. And that's why you see a crazy mixing of these straight lines going in all different directions, because some of those are naturally occurring Hall currents and other ones are naturally occurring smoke plumes. Bad stuff going on down there. And it's enough to start creating its own weather. Let's see what it looks like on the... Check it out. What a disaster. And by the way, the smoke is reaching all the way to New Zealand. So it's even messing with New Zealand's weather. The North Island of New Zealand, about 1,200 miles away, where the skies are turning orange. As the jet stream drags these particulates, which are a net global cooling effect, by the way, folks, things like ash in the atmosphere makes the planet cooler not only via the albedo effect, but by increasing cloud nucleation. If you weren't aware, we're more than happy to inform you of the way atmospheric physics works. And let's look at the lightning. Speaking of atmospheric physics, Not a lot of lightning, but there's where it is. Let's see if we... Oh, we don't want to do that. That's bad news. Anyway, check out lightningmaps.org. It's a good time, especially if you hear thunder. Here is where the jet streams are in the Western world. And don't get bored, folks. We've got tons more stuff to cover, including crazy science stories. Check it out. The jet stream over the North Atlantic Ocean is going backwards. And you see that cold air being injected into North Africa. We could have forecasted their snow if I was looking at the weather there, but I don't. Because I can't forecast the whole world's weather. Well, maybe I can, but not currently until I get paid a lot more money. Anyway, there's where stuff's located in the eastern world in terms of jet stream flow. And that's an odd little eddy right there, isn't it? Let's look at the 10 hectopascal for once from this same view. And there's a 10 hectopascal view. This is the higher altitude winds, or I'll just say higher pressure winds. And let's just put it back to jet stream and move on here, as before the video gets too long. Here's a value-added service for you. It's the U.S. Doppler radar map. And there's snow falling on me right now. Hopefully I'll be able to get to where I need to go to help to protect the food supply. Did you know that 9 out of 10 major organizations have their food tested by a giant multinational company? Anyway, here's some outdated water vapor map for some reason. I don't know why. We're looking at January 4th for some reason here. What is up with that? Hello, NASA goes. NASA goes to not send me data. January 4th. But it's January 6th. All right, well, forget the water vapor map. And thanks, patrons, the real source of funding for the channel. And let me just make a comment about previous statements about YouTube and Google being a scam. Perhaps it's not a scam, as Google AdSense is suggesting that they may begin paying our channel. So we'll see what happens. We'll believe it when we see it. Thanks everybody subscribing on YouTube, etc. And thanks Smash Team, which includes everybody viewing, leaving comments, or on whatever platform you're located on, as we consider the whole thing a collaborative effort. And welcome everybody to the That Is an Ass and That Is a Hole in the Ground section, where we visually explain that this is not vulgarity. This is a pack animal known as an ass, and this is a hole in the ground, otherwise known as a sinkhole. We don't even say any swear words. Very rarely. What's the problem with Americans? Well, let's talk about the way it used to be. The way it used to be in America was Americans were free to keep everything they earned. They were free to decide for themselves what to do with their own money. There were no drug laws. There were no immigration controls. There were no minimum wage laws and very few economic regulations. There were no public schooling systems. There was no gun control. There was no Federal Reserve, fiat money, monetary inflation, or debasement of currency. There was no paper money indeed at all, because the Treasury doesn't even have the right to print paper money, which is why the Federal Reserve... Anyway, I won't get into it. Also, no national security, state, foreign military bases, foreign interventionism, and no denial of due process of law by trial or jury. No unreasonable searches or seizures. In other words, the federal government followed the Constitution. Would you like to read about it? Well, it's by Jacob Hornberger via the Future of Freedom Foundation. We just looked up the Zero Hedge article. Ouch, Constitution. Speaking of ouch, here's your pro-driving tip. Don't be involved in a scene like this, which killed at least 5 people yesterday near Pittsburgh, Pennsylvania, about 30 miles east of it, involving a tour bus, at least 2 tractor-trailers, and countless passenger vehicles. Here's a pro-driving tip. Wherever you're getting, even if it's to surgery or because your passenger is having a baby, is not important enough to get involved in a crash like this, as you might not end up getting there at all. Here's another pro driving tip. Have a checklist of things to do that make you safer and things that make you less safe. And only do the things that make you safer while driving. I know it's complicated, but I'm a professional. So I'm actually paid to drive. I drive about 1,000 miles a week. And there's a reason why I've never even been involved in a fender bender while working for my current employer. And it's because the strategies and techniques involved in defensive driving will not only help you out, but they'll make other people safer. For instance, if you see brake lights lighting up in front of you, please don't speed up to get to the closest position forward because you're in a hurry. Put on your four-way flashers early. All right, here ends your pro driving tips, spaced out viewers. Are you dudes spaced out? Because we've got a cosmology segment coming. But first, we have to talk about the upcoming shirts. Do you want a shirt with 3C405, otherwise known as Radio Galaxy Cygnus A, as well as a link to our website? Well, it's coming. It's coming this month. There's the design. And it's black on black for a reason. If you're not aware of what that crazy looking image is, it's basically a giant galactic megagun. And the projections you see on the left and right are relativistic jets shown in radio frequency of the distant, distant galaxy located 500 million light years away or so, Cygnus A. And here's a cosmology segment, so hold on to your telescopes. And by the way, thanks Terrence, we finally got a coffee grinder, and the Peruvian is delightful. And indeed, we will be messing with the grind, as I don't think I ground it finely enough. We got a cheapo Walmart $15 coffee grinder. And let's talk about geospace, as geospace is part of cosmology, but we have a special section on our forum for this. And we talked about this story, I don't know, about 2 weeks ago, about iron snow in the Earth's core. And I'm not going to get too in-depth into this, but we're just going to recite this article. If somebody would like to post it on the website forum in the Earth geospace section, we'd be more than happy. As I won't get to it today, there's too much stuff to do. Anyway, this has to do with the Earth's dynamo and the way seismic waves pass through the core of the Earth. And I put things in quotes for a reason. It's because there's a lot of conjecture and dispute about what generates the Earth's dynamo and what's causing the anomalies in the seismic waves. I'm not going to conjecture, but we did link to the article, as well as to this article, which appears to show that the moon used to have twice as powerful of a magnetic dynamo as the Earth. In other words, the moon's magnetic field, we can say this, the rocks taken from the moon make it apparent that the moon's magnetic field was about twice the strength of the Earth's. Now, of course, there's a lot of dating of rocks involved in this, but they did take the rocks, melt some of them down in a laboratory, and recreate the fields required, and they could replicate the structure of the electrons, let's say, in the rocks. So this is an interesting article. You're going to hear all about it all over the science wires today, about the lunar dynamo, as the moon doesn't seem to have any sort of a coherent magnetic field anymore, just a bunch of weak magnetic field force lines. So perhaps read about this one. I don't know, you could pause the video if you like. And yeah, it appears that the moon used to have a stronger magnetic field than the Earth, which is pretty interesting. Now, I think there's some problems with the theories as to how the moon's regolith was formed in the first place, considering that they're igneous rocks is perhaps not the most logical conclusion to come up with, but let's don't get into it too deep, as there's a point to these videos. Let's talk about the Earth's dynamo. And this is the problem that we have when talking about dynamos, as this relates to all kinds of things from precession to the generation of plate tectonics to volcanism, but most importantly, the generation of the Earth's geomagnetic field. Now, mainstream science largely believes that there's a solid inner core made of iron and nickel, and then outside the solid iron core, and I assume it's solid because of gravity, it's solid because reasons, and then outside the solid core, we've got a liquid outer core, which is also made of liquid iron and nickel, and the rotation of the liquid iron and nickel around the solid core is what generates the Earth's magnetism, like a giant electromagnet. Two brushes, a brush motor, right? Now, I'm not going to get into theories as to how it's generated. I just wanted to cite for our viewers the mainstream model of how it exists. And then you've got the mantle outside of the liquid iron core. We've linked to this article from NASA, which talks all about the accepted beliefs, I'll say, about the Earth's magnetic dynamo and what's causing the pole shift and all that sort of stuff. Of course, during a magnetic reversal, this is the kind of thing you get, where you could have auroras on the equator. But we won't dwell on it at this point, but this is going to be stuff deeply discussed on the forums. If you haven't been there yet, well, stay tuned. Here's where stuff's located in the solar system. There's where it'll be in a week. As again, the Earth's all by itself on this side of the sun, but Venus and Mercury are making their way around. I like to use in-the-sky.org to make myself a nice animatable sky chart. And I think we're a little outdated here, as it is 4:13 Eastern Standard Time. Anyway, there's where the stars are above my head. If you want to make yourself a star chart, just check it out. Now, we've been talking about Cygnus X3 quite a lot, and we're not really going to go there today. Although, go check out the forum, smashamash.com/forum. If you want to read all about it, we posted tons of articles in there, as well as links and all kinds of other data. This is one of the theories as to how it works, that there's a highly ionized zone around the compact object, which is fairly good science. It is indeed good science. And here's a composite image of Cygnus X3. You got this Wolf-Rayet star, this compact companion, which is at where the white meets the blue here. That's the rotating neutron star. We'll call it a massive radio source. And the red and blue are the jets, the radio jets coming out of the radio source, the red being the one facing away, the blue one being the one facing right toward you. And this is kind of like what you'd call a miniature blazar. It's considered a small X-ray binary, a massive X-ray binary, rather. And let's just say it's interesting. Have you read the high-resolution spectroscopy of the X-ray ionized wind in X3 with Chandra high-energy transmission grading spectrometer? I suggest you do. Anyway, we've got all of those on the website, including that's the same article. And then you've got this one here, photoionization emission models. So it's all good stuff. Now let's talk about bursts, and we're talking about gamma ray bursts, and we're talking about the most powerful one ever measured was measured back in 2019. This was measured in the trillions of electron volts, and the accompanying Cherenkov radiation was indeed detected from Earth. So, back in 2019, I don't remember the exact date, January 14th, 2019, 2 scientific satellites, as well as the Neil Gorel Swift Observatory that we look at all the time on the channel, and the Fermi Gamma Ray Space Telescope. Neither one could observe a trillion electron volt signal directly, a tera electron volt signal. However, When they notice activity, they can signal a more versatile ground-based instrument, and it's MAGIC, which stands for the Major Atmospheric Gamma Imaging Cherenkov Telescope, and they indeed verify the results. You'll see this all over the Science Wire today. Understand, and by the way, we will be heading back to the whiteboard sometime soon. And we're not leaving you the address yet because it's private until we decide to allow people to put graffiti on it. Welcome to the Neo-Renaissance, folks. As things like physics get rewritten before your very eyes, head to smAsho.org. Be an entropy buster. Are you an entropy buster? Be an entropy buster. And head to smAsho.org. Also head to smashomash.com/forum. And come stop by and talk to us about Cygnus X3 and how Schumann resonances don't do anything. Make yourself a signature, etc. on the smAsho forum. Thanks everybody tuning in on YouTube. Please don't forget to press like and subscribe and share on your social media, as the channel is in a massive growth stage here in the year 2020. There's a lot of stuff we'll be doing that we're not telling you about yet, so that you'll keep watching the videos. Thanks everybody tuning in live on Twitch. Thanks patrons, the real source of funding for the channel. We'll be seeing if we are deriving new income streams soon, and we'll keep you posted. Thanks again, all you viewers. Thanks Smash Team for making it a collaborative effort. And stay tuned for bonus sections, as we've got even more things to talk about, where my voice gets so velvety that it tastes as good as Peruvian coffee blends. Now, for those of you new to the channel, I understand the information that we prefer is a bit advanced. Perhaps check out this page. It's nasa.gov/sun. It'll tell you all the mainstream stuff, such as why tech goes haywire near the poles. Did you know why? About the Parker Solar Probe and all kinds of other stuff for you new sun watchers. Here's the magnetogram of the local yellow dwarf, colorized for your viewing convenience. There are the fields associated with sunspot 2755. I wouldn't be surprised to see this degrade to not a sunspot, otherwise known as a plage. Not a plague. It's called a plage. And let's look at the 131 angstroms view here. This is a 48-hour image. Series of images, rather. And I'm pressing the wrong buttons. I'm losing it, folks. Anyway, there's 48 hours of activity from your local yellow dwarf in the aqua blue 131 angstroms view. We are out. Wish us luck. At least once I get to the lab, I'll be driving a four-wheel drive vehicle that I don't own. But I'll be going to some pretty chilly places over some pretty decent-sized mountains. So anyway, since it'll never be now again, may that solar wind be at your back and that atherosclerosis absent from your veins.